Yeah,
That's
you're
why I was
stupid.
asking you how to get to 8 from 6.
Oh, really?
Yeah. That's cool.
Maybe we'll even answer those questions along the way. Absolutely. Let's do this one. This is Vivian's. I'm just going to do it. She did all the work already, so nobody has to be upset that I'm doing Vivian's problem. So I'm going to do my transform. I'm going to let y be the Laplace transform of y. And so hopefully when I write this, that's all starting to look legit. Laplace transform of the left. Are you finding like that this is getting easier? Like you're recognizing the forms and then this side here is going to be 9, and that's cos, so an s goes on top. S squared plus k squared. Okay, cool. And then we, I don't know why I'm becoming German there, but I was just hanging out with a German dude the other day, in fact. Let's see, here's what we got now, I guess. S squared plus k squared equal plus 9. Oh, this is good for you so far. Then divide through, and immediately want a calculator that does partial fractions. One of the parts I love about this is when you're like, oh, I totally know what that is, right? You're like, oh, it's just 9e to the t, that's lovely. This needs some work here. So Vivian, this isn't where you were having trouble yet with the thing?
Yeah.
Okay, so we need to do a partial fractions on this. Let's see if I can just guess it, maybe.
It won't go into the calculator. We did it one of the other classes. It's
Oh,
the K
because of the K.
Yeah.
Okay, let's do it by hand then. That's good. So let's see, we need the S's, oh, we need one, oh fuck, I can't guess that. Okay, okay, so let's just do the work. So we're gonna have 9S. This is kind of fun, this is soothing. AS plus B squared plus K squared. And you know, I think you can break this down into imaginary factors if you wanted. I don't know if I've ever done that, but it seems like it should work. But be sure you have a strong constitution and you know what you're getting into if you do that. Okay, so set up, flatten.
Wait,
So-
why is it BS plus B?
So you have to have 1 degree less on top than the denominator.
Oh.
Does that make sense? So if I had like s cubed down here or something, I'd put as squared plus bs plus c. Glad we had this conversation. So we got as plus b, s minus 1 plus c. And let's let s equal 1 to get 9 equals c times 1 plus k squared. So now I know c, right? And let's write it out because we might need to plug it in somewhere else. And then there's no other good, well, there's actually one other good value. 0 is always a good value to give you some information. It's so easy to work with. So that just becomes b times negative 1. And that just becomes k squared. Oh, look at that. K squared c. And then I can get c from that. And then I would let, oh, hold on, this is fine. This is not going to finish it. So this is going to be, wait. So b equals k squared c, and that's that. So that's equal to 9k squared over 1 plus k squared. So b is that. And then I would actually group terms together to figure out the other things. So in other words, I'm going to FOIL this out. So I'm going to get 9s equals as squared minus as plus bs minus b, so that's the FOIL, plus cs squared plus ck squared, like terms. Oh, there, see, I'm done now. Because I've got a plus cs squared plus other stuff. I don't even care about it
because this has to be 0, right? So this must equal 0 because what's on the left is 9s. You can think of that as a 0s squared there. So a is equal to negative c, and we're good. So let me stop. It's very quiet, hard to say.
Can you explain that part again?
What I did here?
Yeah.
So I'm multiplying out the right, and I'm just using the fact that if I have something times s squared equals some other thing times s squared, that the coefficients have to be equal. So there's no s squared on the left.
Oh, okay, I see.
So the a plus c have to the a and c have to cancel each other. Okay, cool. That's fun. And I think then, yeah, just pop it together, right? And then do your, I don't even know if you have to do the inverse transform on this one, but maybe. Yeah. Anything else? So you feel good on that one, Vivian? Okay, awesome. What else would you like to talk about on the whiteboard? And do we need more time on that assignment? Yes, I'm seeing like a yes. Could someone just shoot me an email, please? Thank you. I think Kidra's doing that. Thank you, Kidra. Maybe I'll just do it too. I don't know.
Oh no, I was
You did?
making that edit
Oh,
the web work. No,
okay, got it,
sorry.
got it. Other things to chat about. Grace was here, right?
Yeah, she's-
Okay, okay.
Yeah.
Is it okay if I erase? Yeah, Chris, yes.
Where do you
yes.
get the negative b plus the k squared c?
I plugged in s equals 0,
Yeah,
so I get 0 equals b times negative 1
yeah.
plus c times k squared.
Ah, okay.
Does that sound good?
Yeah, thank you.
You're welcome. Other things. Is that it for the web work? We feel okay? All right, trust you on that. This is pretty much today's last stuff day, and it's not really new. I just want to put together the things we had last time. And then on Monday, I guess on Monday my plan is to give you your final. Crazy, fucking crazy. But yeah, I'm gonna give you your final on Monday, and like next week is like come work on, there's no new material, this is like big office hours. But you're crazy if you don't come here and work on that, right? Because who knows what I will say? Who knows what help I will give?
Mm-hmm.
Uh-huh,
That's right.
mm-hmm. And I always give shit away. Always. Well, I don't know about that.
Free money?
Maybe I'll put some extra credit on the final if you want.
Yeah, that would be great.
Yeah, you'd like that? I mean, it's like, do it or don't, you know, it's there if we want it.
I didn't do the second exam, so I might need it.
Yeah, very few people did. Like, only one person completed it 100%, and that person did not need it at all, but it was cool to see. One person did a lot of it, and then everybody else did none of it. So, okay, let's have some fun. I always feel like I've used 9. It's, oh, hell yeah, there we go. Let's pick the nice perfect squares. Let's see, so, whatever. Sure. What is the left side model if we wanted to think of a physical interpretation of this? What could I think of X as representing? Yes. That's good. That's like a lawyer answer. That's a good one. Position of what? What do things like that look like? Mass spring, right? Mass spring, is there damping?
No.
There's no damping, yeah. So an undamped mass spring with no initial position change, so equilibrium, no initial velocity, but lightning strikes at 2 seconds into the process. So this is the Dirac delta, and we can think of that as, let's see, here's T. We can think of that as a forcing on our system that is 0 up until 2 seconds, at which point the lightning just comes in and kicks the system's ass and then walks away for just a second. So that's what happens. It's just like literally, think of a sudden, intense force coming into the mass spring system, just whacking the hell out of it with a baseball bat or something. Just an incredibly sudden, instant momentum added to it. So what happens to the system? Well, let's think about what should happen and then see if our intuition's right. So we've got a mass spring, and what would be the period, the normal period of the solution without solving it? What's the period of this? If we just had like none of this, but like the homogeneous part. Just waiting. There we go, thank you. Period 2 pi over 5. Right, this thing out here, this is your like omega squared, and when you get your this thing characteristic polynomial is going to be that. You're going to get plus or minus 5i, and then you're going to have cosines of 5t and sines of 5t. And so 2 pi over 5 would be the period of the solution that I expect. It's the natural resonance of whatever this represents. So if you watched that video that I made, you unfortunately heard me singing at least a scale, a very poorly sung scale. But remember I had that glass there that I was singing to, and it had a natural resonance represented by this side. This was what I was putting into the system. So the system has a structure that it wants to abide by, and that is represented on the left side. If I didn't have if this wasn't here, what would our solution be? What's that solution without solving? Physical interpretation.
Would just be 0.
Thank you. Yes. That's my new thing I'm going to start doing. Just doodling and waiting. Better than just like some sort of stupid fake intimidation, right? So the solution would be 0. It's a mass spring system with no external forcing, no initial position or velocity. The solution will just be 0 the whole way through. And notice that would work. What's the second derivative of 0? 0 plus 0 equals 0. Certainly satisfies the initial conditions. So use that whole, the reason we spent time with that is so you can gain some intuition about what to expect. But let's do the Laplace thing. So I'm going to take the Laplace transform to the left. That's the x double dot. Get back. So let me stop. Letting x be Laplace transform of little x. Sound good? And this is like one of those things, I either know that this has to happen or I have to go look it up, right? So it's like, you can't look at that and then look at that and go, perfect, if you've never seen Laplace transforms. What's the Laplace transform of this thing? What is that thing called?
but it's related. It will produce a Heaviside, but what's that Greek letter? Delta, right? Yeah, so it's like Dirac delta. So that's the Dirac delta function. That's the sudden impulse. It will result in a Heaviside. So this is equal to, this thing here is just the Dirac delta. And as Chris said, like you see this probably at Regis. The only place you're going to see this is in the wave equation if you're doing like quantum physics and things like that. It shows up. Is that what you were doing, Chris?
Maybe.
I like that. I like the caginess of that. Okay, so the Laplace transform of this is just e to the negative t naught s. So that's easy. Let's put that down here. E to the negative 2s. Cool. Now just play our game. Now our games begin. Dead. Left side becomes the lovely dat. Right side becomes, still stays that. Solve for x. And usually you probably want to keep that out in front, so let's just do that. Nothing amazing has happened, right? I'm just dividing. So, and then x, little baby x, is this. Let's refresh our memory on how to do that. So now, as Olivia suggested earlier, now I see Heaviside. When you see this, and you have to do an inverse, it's a Heaviside. And this will always produce a Heaviside. It certainly can easily produce discontinuity because that's what lightning does. It fucks things up. So, I don't mean to get too technical, but that's, I think, what a physicist would say about it. Probably Dr. Gray would say that. Let's write our formula. Recall that L inverse of e to the negative t naught s. The number in front of the s here tells you what time things changed. And then we have f of s. I've used cap f, sorry. I've been using that, just try to keep it. So this comes out in front as a Heaviside. And this becomes L inverse of the thing that's just attached to the E, but then after that transform, T goes to T minus T naught. So, this, take a little turn. So x of t is going to equal the Heaviside of t minus 2. Things click on in 2 seconds. L inverse of 1 over s squared plus 25. And after I'm done, t will go to t minus 2. This is Heaviside t minus 2 times what? What's that? What function is that anyway?
Sine.
That is a sine, yes, absolutely. Very good, very nice. So it should have a 5 on top, right? Like ideally it has a 5 on top. So we put the 5 on and put a 1/5 out in front. So this becomes 1/5 sine of 5t. Let me stop there and let me know if that's okay. Or you need me to see that. Oh, I see someone wrote something on this wall.
That was you, Dr. King.
Was it?
Yeah, that was you like
Yeah,
the very first
yeah, like
class.
really the second or first day, you like wrote, is that -2, right?
Yeah.
You're like, this graph isn't big enough.
Yeah.
Cool. A little.
Sign it.
Okay. So, all right. So I'll take your word for it. We don't need anything else. So we got 1/5 like that. Didn't use parens, so you keep righteous with the distribution, and you know that's shit. There's very little I can do with this that changes it in any useful way for us. But I actually do want a plot of this. So let's look at the solution. If someone could actually plot out just sine of 5x minus 10 for me on Desmos, just so I can take a look at that really quick. That would be great. I'm going to see if I can get it without that. But
So let's convert this back to a piecewise. Be able to do this, because otherwise you don't really know what this is. So this is 0 up until 2 seconds. And then this becomes a 1, and this is our answer from there on out. And that's when t is greater than or equal to 2. So at 2 seconds in, up until 2 seconds, nothing's happening because it was just a dead mass spring system. And then at t equals 2, oh, it's just sine of 0. I think it just does that. So it just kind of kicks it into motion from there on out, and then the amplitude is a fifth. And I think we're good to go. Does that look right? Yeah. Awesome. And it's just a happy mass spring going on forever and ever. We feel good on this? Let's try one together. So let's do one for you, but like kind of like what an final exam problem would be like. Yeah, let's do that. Let's do a little fake. I'm gonna start writing the final right now. This is like the plan. So step 1 is write f of t given by this graph as a piecewise function. So we're going to go up. I'll give you some points in just a second. That keeps on cruising. No, fuck that. No, I don't want to do that. Just that. Just that. And so then that'll be, let's see, 1 and 1. We'll make things chill so it's not stupid. 1, 2, 3, and then 4. And yeah, there we go. And then it's dead. Can you please write this in piecewise form? So that means you need to get the equations of these line segments. So f of t equals, and let's put it, you'll have 1, 2, 3, you'll have 4 different pieces of definition you need. Does anybody else have a mass spring thing for me today? I'll pick that up from you. Thank you.
I read actually in paper, so there's half a slip with some random piece of paper on the back.
Outrageous. That sounds cool, thank you.
I
Very
know
nice.
exactly what you got. MIT.
What, you snagged it from somewhere?
From the OOP office.
We had like a bunch of random just half papers.
Oh, scrap, nice, nice.
ask how you know when you're supposed to use just the less than sign or the less than or equal to, because there's no dots, like you can't tell from the dots.
Great minds, I was thinking about that too just now, so good question. It doesn't matter in some ways on the transition points if you include it, where it gets included. So in general, I would say it doesn't matter, unless it's really obvious, like if I had like this Ella, like it just like it had an open circle and then it dropped, then I would definitely not include 3 for that piece. But when you've got these constructions, you're kind of like, I could have done the equal here or there. Is that what you're asking?
Mhm.
Cool, good
Yeah,
question. What do we have for this equation here? It would be close to negative. It's definitely got a -1 slope, I agree. What would be the y-intercept? Or it needs to be 0 when t equals 4, so what do I need to adjust here? What goes here? Here things.
And t is between 3 and 4?
Okay, I like that. That's something to write. Hell yeah.
Oh, that's what I thought you were asking, sorry.
No, I'm looking for it. Sorry, yeah, it's good. It's good shit. It needs it to happen. What is this function?
1/3.
Wait, are you saying 1/3? So when t equals 4, I need to have a 0 come out, right?
So for that line at least, I have -1/3 d plus 1/3. Since it's
So how'd you get the slope? I think your
hold
slope is
on.
up. Yes, ma'am. Yeah. That slope is a -1 right there.
Yeah.
I see
I
where
think
I see.
1 and 0 4.
I see where you got that. Yeah, this is what I'm looking for. Got it.
I kind of said it at first, but then, alright.
Did you say it?
Yeah, I was like,
I'm sorry.
Wednesday, and then I was like, no, never mind.
Did you say it out loud and I just didn't?
It was like not loud enough.
It's like there's a lot of murmuring. Good job, Nathan. Giving you that one, man. All right, do we feel cool about this? Great, that's problem 1. Step 2, can you find the Laplace transform of that? Oh, no, step 2, write it in Heaviside notation. That's actually the first thing. So use Heaviside notation, h of t minus t naught notation, to write this as an inline function. Hi.
I think you just said this, but I don't know this. So for
Yeah,
the
who knows? Not me.
so whenever you use is less than or equal to, you always include equal to at where it ends.
For
Or where it
For
starts.
one of these, it doesn't matter as long as you're not doubling it up, really. So it doesn't, like here, I could have done this too, Olivia, and it would have been okay, because they're meeting. So when they meet, it's like you can give the point to either piece.
Okay.
Yeah, and I was just doing this because I was actually trying to just maintain a consistency that the thing where greater than has it, but yeah,
Okay.
it could have been the other way too. We are having chalk on the quad day next Wednesday. As many I've gotten some volunteers to help out. That's fantastic. It seems like we'll have to do, I don't know. Our class would, maybe we should all go out and do something. Yeah,
I think that'd be fun.
I think it sounds pretty fun too. I mean, it's just gonna be like hanging out and answering question day, so we certainly can take some time to go out and do some art on the quad. Math art. I promise Dave no obscenities either, so.
like as a reminder, if you're like, I don't remember how to do this, turn it on with a plus, turn it off with a minus, and turn on the next piece. So it starts off with T. I turn off the T at 1 second, and I turn on a 1. I'm going to turn that 1 off at 2 seconds, and turn on a 4 minus T. Or 3 seconds, excuse me. And then I'm going to turn off the 4 minus T after 4 seconds.
So when you're turning off, you don't put the H in front?
These are shared. So I put them in a big parenthesis together times the H, so it does have an H. I mean, you could write this out. Let me write it out the way I think you're thinking about this, Ella. So I could do this. I could say f of t equals t, and then I'm going to turn off the t at t minus 1 second, but then I'm going to turn on the 1 at t minus 1 second. So I think you're thinking something like that, maybe. Notice that I do have that because this distributes to each of those. So I'm kind of clumping together the turn off and turn on together at the, grouping them by the Heaviside they share. Does that make sense?
Mm-hmm.
Cool. And then after you do that, you would want to simplify. And there's only one thing that really needs simplifying, but let's not go any further than simplifying until everybody's feeling like they're coming along. Let's see. And I just like to write things, I don't like minuses leading if I can help it, so that's the only reason I flipped that. Oh shit, no. Yes, fine. What does that turn into, 3 minus t? And let me know, first of all, let me know if there's something wrong. You're all good at that. I mean, I don't mean that in a bad way. I feel like you keep me on. You're paying attention, and I'm always happy to be wrong in those cases. And then let's, you know what step 3 is going to be. It's going to be take the Laplace transform. Oh, I'm sorry. Oh. Yeah, go ahead.
Shouldn't the very last notation be a minus?
Yes, ma'am. Thank you. Good call. Because I turned off 4 minus t. Yeah, solid. Thank you. That's what I'm talking about. That kind of stuff. I need help. I need mentoring and guidance and supervision. Thanks, Lapina. Okay, so let's just do the Laplace transform now. And let me put the formula up to help you remember and just have it here as well. So if you have, then what you do is you've got e to the negative st naught Laplace transform of the function with t replaced by t plus t naught. So remember, you have to modify the thing you're transforming first by replacing every t with t plus the time where the change happened. Simplify that, put this out in front to denote that you got some Heaviside action going on, and then find the transform. You'll want to simplify after you do that too, just to make life easier.
Maybe I'll just write stuff out slowly. That all worked out way too well. I think. We'll find out when we come together. Are we good? Is it good? Yeah, okay, cool. I'm gonna keep on cranking here. You can please let me know if something needs addressing. Nice. Nice. What the fuck? That is crazy. No. Madness. Madness. Ridiculous. Is that right? That looks way too nice. Is anybody else getting that? Sorry, this is gross. It's really itchy.
Could you just explain how, like, the 1 minus t plus 1 replaces the function part of it?
Okay, so, all right, help me navigate.
So from lift your right hand a little bit more. Right hand up there.
Okay.
To the one where you replace it with the numbers. So below.
To here.
Yeah.
Okay, yeah. So what is it you wanted?
Like specifically the substitution in that one specific part.
Okay, so I took, let's see, where we're here. So this was my f of t, right? And what I did was I replaced the t with t plus 4. So I literally just took this expression 4 minus whatever and made that 4 minus t plus 4.
Okie dokie. Okay. I was looking at the other function that I wrote out with the entire thing.
Is it good? You feel better?
Yes.
Awesome. Outstanding. Yes, ma'am.
Why does the, so you have e to the negative s, Laplace 1 minus t plus 1, and then next it just becomes Laplace negative t. Why?
1 minus t minus 1, because that distributed the minus.
Oh, that's it.
And that actually, that's why I was like freaking out, because it happened everywhere.
Oh, okay, because I thought it was an identity that I was
Oh,
supposed to-
no.
Okay.
Does that make sense?
Yeah.
Cool. Yeah, this is like just blew my mind that they all look the same. It's crazy. Then just keep on going. This is just, and then that's just 1 over s squared, right? So e to the negative s, 1 over s squared. I wouldn't, you could get weird with these e's. I would just keep them out in front because they really are placeholders. They're kind of like devices to just let you know what happened there. And you see this and you know there's a Heaviside involved in the whole thing. So, oh my God, wait, oh, yeah, no, we're just gonna leave. I was gonna do something really weird, but I'm not going to, no. I don't think it's a good idea. And that becomes a plus then. So that becomes plus e to the negative 4s, 1 over s squared. Good gobbledygook.
How do we feel about this? Yes, yes. Let me stop, let me make sure everybody's with me. Because we're gonna force a mass spring system with that forcing right there in just a minute and find out what happens. Maybe we'll do something chiller. We won't do a mass spring, we'll just do like a first order so we get the practice of doing that. It can get kind of crazy otherwise. Is it okay? Yes, ma'am.
So why are you substituting, why did you substitute like 1 for t plus 1, t plus 3?
Because that's this rule right here.
Oh,
The-
okay, yeah.
Is that okay? That was easy. Awesome, solid. I saw you looking at that, I was like thinking, I wonder, does that make sense now?
I don't know, when I watched the video, I was like, oh, but I think it makes sense now.
Okay, cool. Other things, right? No? Okay, cool. So, friends, let's then solve this equation. Let's at least start the machinations of that. So what was that, step 4? Step 4 we're on. So, find the Laplace transform of x. So I'm not asking you to undo it yet. If x dot minus 2x equals this f of t. We'll just do a first order. It's not, you can't, like the interpretation's not as obvious at all. Oh, and then how about some initial conditions? Let's just kill everything off because we've got forcing. We don't need stuff to happen at the setup because we're gonna make stuff happen with an external input. You a Floyd fan, Ella?
Kind of. It's my roommate's t-shirt.
Oh, okay. Really one of the greatest groups ever. So, yeah. Oh, this is, I gave you more information than you need. We don't need that second. It won't, don't worry, it won't change anything you're doing unless you're doing it wrong. You just need that. I don't know, because I fucked up. It's a good question, because it shouldn't be. Good one. Does this look okay? Looks like a lot, but when you look at that, hopefully you see that we only need one partial fractions decomposition, right? It's the same thing in every piece. It's just gonna get shifted differently at the end after we undo it. But let's make sure everybody's there. I'm gonna start cleaning up over here so we can take this thing home. And I'll just ask you this like in a minute while other folks are still finishing that. What would have been the solution to this? What is the homogeneous part? Like just think back, what's XH look like? What's that?
Oh boy.
Yeah, wait, what was that? See, yeah, exactly, yeah, it's not too bad, right? You yeah. Yes, ma'am.
Why are we putting x minus 2 there?
Because I divided by, I want to isolate the x, and after I simplify this side, I've got s x. Does that make sense?
Yes.
Okay, cool. Good. Now go ahead and please ask questions. That's the way we do it. All right. So any other questions before rocking? Okay, we're good. All right, we're good. So let's get rid of that. We just know that there's like an e to the 2t that seems to be lurking about in here, right? That seems somewhat reasonable that might kick in. So we need to actually get this dude taken care of. Partial fractions. Let's do that together by hand. You'll be able to use the calculator on the exam, but you know you're here. We gotta. The price for that is to watch me do this now. That's the setup. So you want to make sure that you have every possible fraction that you could combine to get that one. Those certainly would give it, but notice that if I added these three together, the common denominator would be that as well. I would still need an s squared. So I gotta have that most general thing under there. And then I plow through and create a flat thing by multiplying by that denominator. Oh, whoa, easy, my God. Pick some nice values. So I'm gonna let s equal 0, that's happy. And I get 1 equals negative 2b, because everything else dies. E equals negative a half. See that? Just let me replace an s with 0 in this. Dead, dead, negative 2b equals 1. Then I'm gonna let s equal 2. And I'm gonna get 1 equals dead, dead for s, or for c. So c is a quarter. Nice, not bad, like really nice. And then the last one's gonna be a bit of a pain, but I'm gonna play that game I did last time. And I could like pick another s value. Let me just talk about this for a minute. I could like let s equal 1. Let's do that for a minute. So I could pick s equals 1 and get a new equation. That would be 1 equals negative a minus b plus c. And since I know b and c, I now own a. Well, hell, let's just do it that way, right? Why go do it another way? So 1 is equal to negative a minus b plus c, so a is a quarter, 3/4, yeah? Wait, negative 3/4. Is that right? Because there's negative in front there, right? So that's 3/4. Oh!
1 minus 3/4.
1 minus 3/4 is negative 1/4 is what I mean, okay. Yeah. Thanks. All right, so cool. Now we did it the painful way, but we do have our decomposition. It's going to be this, negative 1/4 was B?
Negative 1/2.
Thank you, negative 1/2 and then positive quarter. Cool. Can you do the inverse transform of that in your head? Let's practice. Do the inverse, just, what is the inverse transform of that? Because we're gonna need it 4 times.
Negative 1/4, negative 1/2 D, and 1/4 E to the 2D.
Damn, that sounded good. Thanks, Lavina. Yeah. So, constant, right? T, E. E to the 2T specifically. So, good. We are set up to just rock out the solution here. In some ways, that's like the hardest part. I'm getting you off the hook for the hardest freaking part of Laplace transforms, which is this. Yes, ma'am.
I have a question about the partial, but I don't know. Why, for the, like, 3 different denominators, why is S one of them?
Because it has to be the most general thing that could add up to that fraction. So if I asked you to add these fractions together, Ella, you would first get a common denominator. That's the common denominator. But if I don't have this in here, I'm missing a very important potential input to creating that fraction. So I've got to have the most general thing that I can here. In fact, I'll be so bold as to say that you cannot pick a number A and a number B to make those two add up to that. You gotta have that over S thing. You just can't. Let's actually, let's just see. Because I just want to see, because I made a bold claim that you can't do that, but let's just see. So what would happen if I did this? So let's see, multiply through by this denominator to get 1 equals A times S minus 2 plus BS squared. Just multiplying through by this denominator, canceling respective things. So let's see, when S equals 2, we've got, now it's gonna look like we have a solution. When S equals 2, I got 1 equals 4B, B equals quarter. The same thing I got over there, right? And then when S equals 0, I've got, let's see, what are we gonna get? We're gonna get 1 equals negative 2A. So A is negative 1/2. And that all looks peachy keen. What could possibly be wrong with this, right? So let's test it. Let's see if that worked. So, because right, we see that thing over there, and somehow that's not over here. So what happened? Well, let's add these two fractions together. So negative 1/2 over S squared plus 1/4 over S minus 2. Let's add those. So this one I need to multiply by S minus 2 over S minus 2. So, and this one I need to multiply by S squared over S squared. And I'm actually quite curious what's going to happen. I'm hoping the hell something bad happens here. I see something bad happening. Look at the top. That top, not going to be nice. Not going to be 1 for damn sure, right? Because you got this S squared and they can't cancel. So just to make everything work out, I've got to have that extra thing in there.
Okay.
Feel better?
Yes.
Yay, cool. That's good. I don't think I've ever done that, so thank you. That's cool. That's a great question. That's a I give a shit question. I like it. Okay, so now x of t equals the L inverse of this madness. Let's not write it out again. Let's kind of just like put the first term in here. And then we're gonna have, let's just kind of put little place markers here, because we know that this expression is gonna go onto each of those. And then we'll just put like a little box here to show it's the same damn thing in each of those. Just to kill the pain a bit. So this, we had to do that to do. So this is actually L inverse of -1/4. Oh, hold, let's do one big, sorry. Let me take that back. I'm sorry. I'm glad I didn't spend a lot of time writing it. Let's just do L inverse of this, because that's what we're gonna need, right, in 4 different ways. So L inverse of this beast, that's what I want next. And we already did that. Lavina read that off to us, and then we agreed with her that this was -1/4 minus 1/2 t plus 1/4 e to the 2t. Yeah, that's good. And so, now I can get this real easy. So x of t, so, comma, a little flow there, minimal flow, equals that. So that's the first thing. So first off, it starts off like this. And then minus Heaviside t minus 1. This with t replaced by t plus 1. So let's call this expression just, I'll give me a cool variable, c of t. Or whatever, just make up some symbol. I just like c, I like saying c, I like making a c, because you cannot go wrong making a c. Use your favorite letter. Call it that of t. So this is going to be c of t plus 1, then minus Heaviside of t minus 3, c of t plus 3. See why we're not doing this in class too? How many problems could I put on the final if we did it in class? One. One problem. And then plus Heaviside t minus 4, c of t plus 4. So that is the solution, but we're gonna make it look intelligible, because that isn't very helpful. First we have to rewrite these 3 things out. So that is -1/4 minus 1/2 t plus 1/4 e to the 2t minus Heaviside t minus 1. That with t replaced by t plus 1. Oh, fuck. It's just a lot of work. Isn't it time to go yet? No? Okay. So -1/4 minus 1/2 t plus 1 plus 1/4 e to the 2 quantity t plus 1. Oh my God. Sometimes I like to give gifts to future me, you know, and like, this one's out to you, future Timmy. This one here, I'm flipping the bird to pass Timmy. All right, so then we got minus h of t minus 1, -1/4. Well, it's all just a lot of the same. Wait, plus 3, sorry. Yes, minus 3, t plus 3. I'm going to take a picture of this and I'm going to graph it and send you the picture, but I'm not going to do it in class because I want Desmos to do this for me. But I will send you out a cool picture of what this sucker looks like, and we're still not done. Boom. Okay. I'm going to leave that forcing function up. So now, ideally, and what you'll get to do is to convert that back into piecewise form, and then we've reached completion. So we have to move backwards, reading the Heavisides backwards. So let's do that. So finally, so in piecewise form, x of t equals, give yourself a splendidly big bracket. Brace, whatever those are. And we're going to start off. So when t is 0, so when before 1, when t is less than 1, this is off. This is Oh, this is off, this is off, this is off. So the only thing that happens before 1 second is that little piece at the beginning. So we got -1/4 minus half t plus 1/4 e to the 2t, and that is there. Then, when t equals 1, the minute we get to 1, this piece kicks in. This turns into a +1. This turns into a +1. This is still off and off. So just think of this now, it becomes minus this stuff. So here we're gonna get this thing literally minus almost itself. Let's see if I can, so I'm gonna do a little simplify. It's 1/4 minus 1/2 t minus 1/2. Just that little bit there. And I'm gonna combine that with this. So notice that the -1/4 minus -1/4 is dead. -1/2 t minus -1/2 t is dead. So these two pieces cancel in the next bit, and I'm left with 1/4 e to the 2t minus 1/4 e to the 2t plus 1. And when I say t plus 1, I mean it like that. So check that out, and let me stop. What did I think I might have missed one other. Oh, right, this minus a half, right?
Yeah.
Yeah, I forgot that. Okay, so the minus a half, indeed. Minus a half in there. Yes. Yeah. And then depression sets in, because we have to do that 2 more times. But that's not too bad. He said to himself, what do we have there? What's the next time? 3? Yeah. Okay. So at t equals 3, we have this minus that. So now we just have to take this and subtract off this beast here. So we're going to have a -1/4 plus, or you have -1/2, I'm just looking at the constants, plus 1/4, that turns into a -1/4. And then we've got -1/2 t. So that kicks back in, so now we got another ½ t in there. Or does it become plus? It becomes plus 1/2 t. Because minus. And then -3/2 becomes plus 3/2. Plus 3/2. What's 1/4 plus 3/2? 6/4, 5/4. And then this nonsense minus this beast. And then these two are still there. So let's see, so we've got 1/4 e to the 2t minus 1/4 e to the 2t minus t plus 1 minus, it will be a minus 1/4 e to the 2t plus 3. And then, oh fuck, I'm not doing the rest of it, and you don't want to see it. Nobody wants to see it. Whatever. More of the same. I will take a picture of this. I'm going to take a picture of this and do it all and send you the beautiful graph. Let's see. I think we're done for today. I think that's it. How can you not be done after that? Do you see what's going on? Yeah. In painful detail. Yeah. You're welcome. Good. Alrighty, my friends. That was the last day of DiffyQ proper. Crazy, right? Yeah. But we have more time. We have 2 more days together to do what we want. It'll probably be the final, but you know. And then we'll go do chalk. We'll definitely all go do some chalk shit out there. Thank you. Yeah, you guys have something to talk about? Or just watch the rest of the team? Nice. It's whack.
It's so
It's
Yeah.
awesome.
This week is going so fast. First time we're talking about that earlier. Like,
What?
it's just
I
it's
know.
going by so quick.
I think yesterday I was a freshman.
I feel like I'm a freshman still.
Do you?
I get a little confused sometimes.
I was taking a test one day, Justin, and I wrote 2017.
You did
No, I kid you not. Oh yeah, no, that was a sad moment. I know.
What class was that?
Physics.